Hello everybody and welcome back. Welcome back to Section 12. Section 12 is wiring methods. We use this part of the code book way more than we use a lot of the other sections. We use Section 4 considerably. We use Section 26 considerably. But 12 we use it a lot. Everything right from the beginning for undergrounds, and then we also go through when we look at different types of materials for cables. We also look at raceways. We may spend a few minutes at the end of this just to do a quick little Section 12 review. All right, let's go into the changes for 2021. Okay, addition and clarification. So, addition for clarification, wiring in ducts and plenum chambers. So, where a furnace cold air return duct is formed by boxing in between joists, and these are wooden joists. Wiring methods specified for this section for the use in this particular location shall be in accordance with rules 2130 and 2132. What are those rules? Well, let's just pull those up and have a quick look. And that's the wrong book. That's the handbook. We want this book. Let's go into section 2 here. And here we go. These are the flame spread requirements for electrical wire and wiring and cables. And again, flame spread requirements for totally enclosed non-metallic raceways. And I also have it written in here as well. So, addition for clarification, the wiring in ducts and plenum chambers. So this is a handbook note. And we talked about the handbook a little bit at the beginning. We use the handbook regularly to help with rule interpretation. Regarding Subrule 5, the flame spread requirements for insulated conductors and cables and totally enclosed non-metallic raceways are set out in the National Building Code of Canada. In BC, we call it the BC Building Code. For example, the type NMD90 non-metallic sheath cable is permitted to be installed in a cold air return duct in a single dwelling when the duct is formed by boxing in between wooden joists. The intent of this rule 2130 is to limit flame spread and smoke propagation in cables in plenum spaces to the values specified in plenum requirements in Article 36431A of the National Building Code of Canada. Authorities enforcing provisions of the National Building Code of Canada and the National Fire Code of Canada in each jurisdiction should be consulted to determine the acceptable volume of cables in plenums for the purpose of conformance with the National Building Code and the National Fire Code of Canada. So this is just a quick example, and this was, I think this is either out of the handbook or the appendix. So this is the wooden member of the joist, and this is a piece of sheet metal that's nailed onto the bottom. At some points we've even seen it as cardboard. There's no hot air running through it, it's only room temperature air. This is a picture of a computer room floor, and the change in the rules coming up next. And so this actual chamber below the floor is actually return air plenum. The air conditioners are always in place here, and the air conditioners are actually pump cold air down through the floor and up into the equipment to keep everything cool. So, additional rules for clarification. To connect and interconnect data processing and similar systems, portable power cables shall be permitted to be installed under raised floor, pass through an opening in the raised floor located directly below the equipment, and terminate at the equipment supplied, provided that the cable contains a bonding conductor. The connection between the portable power cable and other wiring methods is made in a junction box or similar enclosure, with a conductor termination that is suitable for the class of strand based on the conductor use, and the cable is part of a factory supplied data processing and similar equipment, or of the type listed in Table 11. What this is saying, so if we go back to this picture here, if there was a piece of equipment in here, it could be connected under the floor. As long as it was an approved box, as long as the piece of equipment that was in this cabinet had a manufactured cord going down inside here. And carrying on with that, the cords are cables installed in accordance with sub shall be not exceed 4.5 meters in length. Be provided with strain relief connector where they enter a junction box or similar enclosure, and be installed in accordance with the manufacturer's instructions, supplied with the data processing equipment. Subrule 4, junction boxes installed in accordance with subrule 2 or 3 shall be securely fastened in place and protected from mechanical damage. Often junction boxes in computer room floors are not secured. They're often laid there, so this is actually telling you it has to be secured in place. This is a good change, and so this is what you would call a Q-deck roof, and this could actually be may not necessarily be a roof. This could be a floor pour, but by the looks of this here, this is an actual roof. So in the industry, we look for any possible way that we can get our wire to wherever we need to get it with the shortest route, and also with the least amount of labor. It's just the way our industry works. So this is the roof. Now, this is the underside of the roof, and we often will secure our pipes to the roof. And in the fashion here, this is not uncommon. We see this all the time. We have a junction box. We have a piece of, this is either a tech. It looks like probably a tech with it stripped back as such. And this is going up to a rooftop unit. And we have raceways on the surface. What the new rule, and this is cables or raceways installed in roof decking systems. So this is if you were to install it in the roof, and we've been doing this for a number of years, and this rule here actually says no more, and there's reasons for it. Cables or raceways installed in accordance with this section shall not be installed in locations concealed within the roof decking system where the roof systems utilize screws or other metal penetrating fasteners. There's a lot of screws that go through this stuff. If you're ever working underneath Q-deck and scrape your knuckles, you'll know. Notwithstanding subrule 1, the following circuit shall be permitted for installations in locations concealed within a roof decking system. So, these are the rules. Class 2 circuits in which the open circuit voltage does not exceed 30 volts. And B, embedded trace heat. So the trace heat would be for melting snow. Subrule 3. Where wiring is concealed within the roof decking system in accordance with subrule 2, a warning label shall be affixed. B. At all permanently installed roof access points where provided and in conspicuous location in the roof area where the wiring is installed. So what this is saying now, no more than 30 volts, and it could only be embedded heat trace, and you have to label it. So this practice here, where the X is, was done commonly. And where we used to see this was for lighting. So if we go back a couple of pictures here, say I had a light at one end of the flute, and then 50 feet away, I'd light another end of the flute. Well, it was really easy to run a piece of BX through the flute. And you drilled a hole with your unibit, and out you would drop 5 feet of AC90 out of both ends. It was done in the industry. This is now saying no more. So you used to daisy chain a lot of your fixtures like this. You could have brought them out. You could have brought them through here, through the flute, a couple of cables in the flute, and you could drop them out for junction boxes. It was really commonly done. This was an industry working practice. Now it is no more. So going back to here, no more putting raceways or armored cable in flutes. This here would have been the foam, and then there'd be a weatherproof membrane over top. Because there's screws going through it, can't do it anymore. So a little bit more. So here's the Appendix B note on this rule. For the application of this rule, the surface area below the actual metal roof pan and the attic space are not considered part of the roof decking system. Where the roof decking systems are mechanically fastened using screws or other penetrating metal fasteners, exposed cables and raceways could not be attached to the roof metal pan system until substantial completion of the roof decking system mechanical fastening. It is not the intent of this rule to require the relocation of existing cables or raceways when the roof decking system is repaired or replaced. Installation of insulated conductors and cables. Insulated conductors and cables shall not be handled or installed, liable to cause damage to the insulation. And such insulated conductors or cables shall not be installed so they permit flexing and movement of the conductors or cables after installation if the ambient temperature is liable to become too low to damage the insulation during flexing or movement. Except as permitted by other rules of this code, insulated conductors and cables shall be of the type specified in Table 19 for specific condition of use. Now, one thing I would just like to have a quick peek at here before we go too far is I would like to just bring up that rule quickly. Let's have a look at Table 19. Table 19 is revamped. Table 19 has been redone. So this is what bringing forward with this rule is actually bringing you, or this change is actually bringing you forward to Table 19. You note here, we've got location is dry, damp, wet. RW90 cannot be used in wet location, but it can be used in, or R90 can be used in dry and damp. For instance, we could go through to, so these are conductors. Non-metallic sheath cable, NMD90. It is approved for dry and damp locations. Okay, check. It's a 90 degree. Can it be used for consumer services? No. Feeders? Yes. Branch circuits? Yes. Control and instrument and circuits? No. Class 2 circuits from section 16? Yes. Fire alarm? See, there's a note here. 32100 and 32102. We're not going to go into that. Can it be exposed? Yes. Can it be concealed? Yes. Can it go in a raceway? Yes, it can. In cable trays? No. Do not put NMD90 in a cable tray. Outdoor overhead? Nope. In plenums? Nope. Cannot go in plenums because it only has an FT1 rating. Exposed to sunlight? No. As direct burial? No. But note, this next row, NMWU, can be direct buried. So all of the types of cables here are listed. And note that these are cables not having metal armor or metal sheath. Now, if you go along, these are cables here. And fire alarm and signaling cables. They've done a very nice job of doing this now. Cable having a metal armor. AC90. And we've got ACWU, we've got Tech 90. Everything is a 90 degree. And talks about all of locations. All of it can go into a cable tray. Can you use it for fire alarm? Let's see here. Outdoor overhead in plenums and fire alarms. According to rules in section 32, yes. Can it be used for controls yes? So it's yes across the board. Okay. Cables having metal armor. So this is listing all the designations, and then it's got the use for each. And location, dry, damp, and wet. I think they've done a very nice job of this table 19 now. Communication cables. Communication cables. So CMP, CMR, 60 degrees C, dry, damp. Can't be used for branch circuits. Can be used for class 2. Exposed and concealed, you can put it in a raceway. You can put it in plenums. If it has the appropriate FT rating, of course. All right, let's go back. I just wanted to get sidetracked there for table 19 for just a moment. And so the maximum allowable conductor insulation temperature. So the change in this rule is more about table 19. A revised rule, maximum span of overhead conductors. Spans of single conductor or cables run aerially between buildings or supports of the same premises shall not exceed 4.5 meters. The rules are pretty much identical. But now we have a reversed rule where it said we weren't allowed to run conductors over a building. We now allow conductors associated with a building shall be permitted to run over the same building. This rule has been changed. New title, overhead installations. So the rules are all the same. Messenger cable. Messenger cable shall be bonded. So what the messenger cable is, if you can imagine if you live in an area that you have utility poles and you've got BC Hydro on the top or in the middle, and then you've got Shaw and Telus below. Well, Shaw and Telus, they're the utilities, so it really doesn't play in. But if you're stringing a messenger between the poles to run cables on, that messenger is a metallic cable. That cable must now be bonded. And these are all the rules regarding, and this is the specifics for the actual messenger cable. So what it is, cable ties shall not be permitted as sole means to lash insulated conductors and cables to a messenger. So if you've ever witnessed, or if you have involved with a line company or a communication utility, they often have what's called a spinner, and the spinner is pulled along and it actually spins a stainless steel thread all the way around it, which binds it all nice and tightly together. Tie wraps, even the black ones over time, will fall apart in the sun and the heat. I'm really glad this rule has actually come out, been revised. Protection of cables in non-concealed locations. So there's been a lot of debate about this rule and whether the cable goes on top of the board or the cable goes beside the board. So there's been clarification in here. So now it talks about cables shall be protected from mechanical damage in the form of running boards or guards, strips where they installed in the following location. The upper faces of joists, of ceiling joists, or the lower faces of rafters in attics or roof spaces where the vertical distance between the joists and rafters exceeds a meter. The lower faces of exposed ceiling joist upper face, the open face of wall studs, or where the cable is exposed and is installed less than 1.5 meters above the floor. Running boards and guard strips shall be at least 19 millimeters by 38 millimeters at the edges of the running board. Shall be projected at least 12 millimeters beyond the cable. So you have to make sure that you are at least 12 meters, so that's roughly half an inch. You have to make sure the cable is at least half an inch back from the edge. And there's now more language around where it goes on the edge, and you'll see that in another rule as well. And they've actually put a rule in the Appendix B. They've put a diagram in the Appendix B now. So I think this is pretty clear how you have to install running boards and where the cable goes on the running boards. They've actually put a detail in here for you. Now, this is 12516. This is an interesting rule. We've always paid attention to this. Most contractors are good at throwing in protection plates, and there's a rule in here that's going to catch a lot of people by surprise, and we're going to go over that because I really don't want to see individuals having to get called back to make corrections. Corrections cost money. That's reality, and nobody wants to give away money. Subrule 1, where a cable is run through joist or similar members, the outer surfaces of the cable must be kept a distance of 32 millimeters from the edges of the member, or the cable shall be protected from mechanical damage by A protector plate covering the width of the member, or a cylindrical bushing sized to the hole through the member and extending a minimum of 13 millimeters beyond both sides of the member. Typically all I've ever seen installed and all that I ever used to install would have been the protection plate. So this rule has not changed. Now, this is where there has been a change. So subrule 2, where a cable is run along studs, joist, or similar members, the cable shall be kept a minimum of 32 millimeters from the edges of the members that can be covered by drywall or a similar material, or protected from mechanical damage by corrosion resistant non-ferrous metal not less than 1.3 millimeters thick, securely fastened in place, extending beyond the face of the member in such a manner that it will cover the width or group of cables. So this is one that's going to catch a lot of people off guard if you're not aware of it. And this is in cables in concealed installations. So I do have a couple of pictures in here, and it's not this one. This is an example where this would be a non-compliant installation. So this installation, they're compliant running through the studs. They're less than 32 millimeters away from the surface. 32 millimeters is 1.25 inches. 2x4 wall, a hole in the middle, you'll be okay. This is where it'll not be okay. And they actually need a protection plate up there too. So this cable here is less than 1.25 inches away from this front edge. So they would have to put a protection plate all across here. Protection plates would have been required on the back side of this. So I would like everybody, if anybody walks away from this course, this is one that's going to save you grief to do it now. Because it is one that you could get caught off guard. There are products out there. You could do, you could use lumber. You could also use, they make ladders that have 2 screws to hold the ladder in, and you can tie, they actually have clips that hold the Lumex in. This is an example here of the protection plate. So less than 32 millimeters from here to here. protection plates required. This also talks about the protection plate required if you're renovating and you remove the baseboard. And we've seen that. So do not get caught on this one. Now, they've also gone into where this rule here used to point back to Lumex. Now it actually points back to, they've actually listed in it now for armored cables. So for AC90, so let's just see here. The armored cable is run through studs, joists, or other members. It shall be located so the outer surface of the cable are kept 32 millimeters from the nearest edge. So this talks about through, okay? This talks about through only, protected by mechanical damage. Now, this does not talk about where it runs up beside the stud. As in here, it talks about where the cable is run along studs. So Lumex, through the stud, run up the stud 1.25 inches. AC90, where it runs through the stud. Okay? Remember that one. That'll save you a lot of grief. Pipe fill. So updated rule. The maximum number of insulated conductors or multi-conductor cables in one. This is, I think everybody's pretty well aware of. You can size put the number of conductors into a raceway. You size your raceway based on table 8. Percentage of fill determined by the number of conductors. And tables for and allowable fill for various sizes of conduit. Table 9A through 9H. And we also look at when you do table 8 to 9, you have to take into account table D or tables 10A to 10D for the type of conductors going inside those raceways. Or you could just go to 6A through K. But if you're trying to maximize a raceway, 8, 9, and 10 will definitely get you more conductors in a raceway. Tables 6, 8 through 6K is very conservative and is based on the smallest raceway there is. Notwithstanding sub-rule 4, the maximum permitted number of conductors shall be determined by the summation of the cross-sectional areas of all conductors, and the value to which shall not exceed the limit set out in 9A through 9H for the specified conduit or tubing. Maybe later on this course we'll actually do some pipe fill calculations. We'll see how much time we have. Cable tray. So cable tray now, as we talked about earlier, is only a supporting means. Is no longer considered a raceway. Cable bus. Cable bus shall be permitted to extend transversely through partitions and walls, including firewalls, provided that the section within the wall is continuous, protected by physical damage, unventilated, and where applicable meets the requirements of Sub-Rule 13. And that was it for Section 12. Section 12 had some good changes. If you're into, if you do anything other than institutional or even institutional work, but if you're not in a plant, I'll say plant type environment, you will run into these situations where cables are running through studs. And this is a big takeaway that could, you don't want to have to go back to make corrections and repair mistakes. That's it. See you for the next change. Back shortly.